Hello everyone, welcome to lecture 7, and in this lecture we will talk about databases and PHP. Finally, we will be doing something really meaningful, right? Any web application, especially the dynamic one, has to use databases because at least we need to be able to store the data somewhere, right? And we should be able to efficiently retrieve the data or insert something into the database, right? So we're going to learn how PHP can interact with the databases. We'll talk about databases in general as well, and we'll set up our first MySQL server. It's a server-based database, and then we'll use certain databases to practice our SQL skills, right? Okay, so the outline is we'll talk about the database basics and then the basics of SQL and then some queries, and then I'll show you how to use PHP to connect to the database, okay? So in this lecture, we'll talk about one particular type of databases. It's called relational databases, okay? And these are way more commonly used, okay, database management systems nowadays. But of course, there are many other types of database management systems that are not relational databases. For example, many call them NoSQL databases, okay, but it's just an umbrella term for many different databases, like, for example, the text processing database, okay, where you can go and search text, unstructured data, or documents, okay, where the structure of the object, that can be different from object to object, right? Document-oriented databases like MongoDB, or you can go and talk about like graph-based databases as well. So these are typically non-typical databases that are commonly used nowadays too, but most of the times, like 90% of the times, you'll need a relational database. A relational database is a database which where your data is associated with tables, and every instance of data is associated with a row in the table, right? It's sometimes called a record. Okay, if the table row is called a record, and columns represent the attributes of your record, of your data, right? So, and we have a standard language for that, for querying such data from the relational databases, and we use SQL, or structured query language, okay, to define the data that we're trying to store, manage it, okay, and at the same time search the data, okay, from those tables. Okay, why do we use relational database management systems nowadays for business purposes, especially? Because they're powerful, they're extremely fast to search, okay, and in retrieve data. It's easy to go and insert things because of an efficient data structures. It's also easy to combine data from multiple different sources, from multiple different tables. Okay, so it like joining data is also very quick. Also, okay, you can scale it up very quickly. Okay, you can store your large data in multiple computers. Okay, in a distributed fashion. Okay, relational database management systems provide you this kind of capability. Also, it's very safe in the sense that like all your transactions, they maintain some sort of an atomicity, okay? So either your transaction will be processed by the database management system, or it won't be processed at all, okay? So that kind of gives you database integrity, meaning that, okay, your database will never have a transaction which is partially executed, okay? So that's very important for complex operations, okay, for transactions that involve multiple updates and in multiple different tables, right? So you want to make sure that your entire transaction, which is represented by multiple updates in multiple different places in your database, is kind of represented as an atomic unit, and it has to be executed as a one single transaction or not executed at all. So it makes your database safe. It makes it makes sure that it is okay. It keeps its integrity, and consistency. Okay. Another important feature of relational database management systems, and in most of the database management systems nowadays, is its ability to manage concurrency. So multiple users can connect to that database management system at the same time. They can view the data, different parts of the data, or maybe they can view the same data, okay? Or they can go and edit the data. So database management system can manage concurrency. It will prevent the problems of concurrency, like data read or phantom update, or so all these kind of issues that the concurrent data operations actually cause. All those kind of problems can be solved. Okay, they are already solved by the database management system, so they just kind of prevent users from kind of overwriting or reading certain things in a wrong way, okay, from the same data source. And I think the most important feature and aspect of a database management system, a relational database management system, is its ability to abstract different layers of data. Okay, so when we are storing database, okay, when we are storing a data in a relational database management system, okay, we are not exactly storing the data in the same way as it is, okay, physically stored in a file. It could be stored as a tree, or it could be stored in some other sophisticated data structure, like, I don't know, B trees, for example, right? So we don't need to understand how this data structure is actually implemented. We don't need to understand its operations, and these data structures are like used just to make sure that we can go and retrieve data or insert data to this data structure very quickly, right? So as a programmer, we don't really need to think about the way how these data structures are actually implemented. All we care is just the abstract representation of our data in the form of tables. We assume that our data is stored in tables, right? But it's not exactly the same thing. The table is just our abstract vision, abstract way of interacting with our data, right? But our data could be stored in multiple different ways, okay? So, and obviously, we don't have to go and understand this implementation. We can go and abstract that out and then make our applications, okay, work with this kind of abstraction of tables, and use this particular language, this declarative language like SQL, to retrieve the data or to update some data into our database without knowing which processes are involved, which implementation details are there inside the database management system to make our data so efficient and easy to retrieve and update, right? So all of that thing makes relational database management systems so powerful, because it takes very, very little time to learn how to interact with such relational database management through the language of SQL, and it makes developers, okay, kind of less aware, okay, about the ways how database management system works, okay. So which is good. Obviously, the developer doesn't need to know how DBMS works. Okay, there are a lot of popular different database management systems available. Okay, Oracle is one of the most popular and commonly used database management system, but it is the proprietary one. Okay, the user needs to pay a license fee for that. And same goes for Microsoft SQL Server. Okay, it's also proprietary database management systems that are supported and licensed by private companies. Okay, so but we also have ample of open source and free database management systems like Postgre and SQLite and MySQL. Okay, so these kind of database management systems, they differ based on their features, based on their additional capabilities for, let's say, doing certain things on SQL. Although the SQL language itself is a standardized language and all of its syntax is kind of a standard, the vendors like Oracle or Postgre, SQL, they put additional features into this SQL which make them slightly different from one to another. But most of the times the standard SQL is applicable in all of these, okay, languages. Okay, there could be small differences that you just need to know, okay, because it's just that particular, okay, database management system, and these capabilities are just simply kind of embellished, okay, into the language, so you can go and do certain things, okay, in an easier way. Okay, and also one more thing that kind of distinguishes a certain database management system from the other ones is their size, the way how they can be set up. Okay, for example, SQLite is a transportable, lightweight, free open source database system. It doesn't commonly use, okay, client-server architecture, but again, it has certain features where you can set up a client-server architecture right on that same computer, kind of a standalone system. But most of the time, SQLite is used as something that comes as part of some software, okay, where like you don't have to go and set up a server and then make sure that your application connects to that server database management system and then sends the data back and forth, okay, over the network. So sometimes you just want to keep the data locally but still want to use the features of the database management system. In this case, people go and use SQLite for its transportability, for its portability, because, okay, you can ship it right away to your user, okay, with this particular database management system. All of its logic is kind of embedded into the okay, libraries that you import, okay, into your project, okay. So and these libraries already contain all the processing power, all the muscles, okay, for processing data, okay. So to deal with the files that SQLite creates. Okay. On the other hand, for example, PostgreSQL or MySQL, these are kind of standalone database management systems. They work as servers, and they have all the necessary power to deal with your SQL queries and deal with huge different data in a client server approach. Okay, so your clients simply go and ask your MySQL to give you all the data that you need. Okay, and they just go and do that, okay, on a separate computer as a separate application, which kind of relieves the burden, okay, from the client to the server. So the server basically takes that particular burden to deal with the data, okay. So client simply goes and presents it to the user, okay, or just takes some input from the user. Okay, so that's kind of some other way of organizing your, let's say, applications, okay, using like powerful database management systems like MySQL. So in this particular like lecture, in the Internet Programming lecture, we will use server-based database management systems like MySQL. Okay, in particular, we will use MySQL because it comes as okay, as a default database management system for XAMPP that we already installed on our computers. The XAMPP is just a bundle, right? Bundle of different software that we'll need to set up our development environment for web programming, right? Okay, good. So so let's go ahead. Okay, so MySQL is the one that we will need. Okay, good. So yeah, before we go and start reading about the different databases, I just want to show how we can go and turn on our MySQL database management system on our XAMPP. Okay, so first of all, you can go and I'm pretty sure you already installed XAMPP, okay, because you've been using the PHP, right? So you can go and search for control panel, okay, if you're using Windows, okay, and then you're gonna find XAMPP control panel, okay. If you don't see something like that, you can go to the folder wherever you installed your XAMPP. For example, I installed it here, and then you can find this particular application, right? So XAMPP control.exe. If you go and start this application, okay, it will show you this kind of, okay, window, and in this window you have a bunch of buttons, okay. So In this case, we will need to start two services. Okay, the first is the Apache server, and the Apache server is the web server which will host our pages, web applications. Okay, so where it will host our applications. So if you go back into your XAMPP folder, you're going to find here the htdocs folder. So if you go and place any file or any folder, okay, for example, this lecture 4 folder, right? So I mean, just create it just for as an example here, right? So I can go and create a folder here, and I can go and put some PHP file inside it, okay? And okay, so yeah, wait a sec. I think okay, so let me go and create one more. So I can go and I can come here and then try, say, localhost. Localhost. So you see that the port numbers are default 80 and then 443. So I can go and let's say this will be my public folder, and I can go and just say, for example, localhost, right? And it will open me a dashboard by default. This dashboard contains just the information about this particular web server, all the software that is installed here, and everything. Okay, so I also need to start the MySQL server, because now it will go and start a standalone MySQL server. So how do I know that MySQL server is now running? Okay, because first of all, it is just green, and you can see that the default port for MySQL server 3306, okay, is also on. Make sure that these ports are free. Okay, if it's not free, then try to find the program that is blocking these ports, okay, and just kill that program. So in this way, you can go and start these services on your computer. Okay, just to show you that this htdocs is in fact the folder on which your web server will be serving the pages. I can show you that. Okay, I can go and type in lecture 4. Okay, so it has to open this particular index.php file. So I can go and say lecture 4, for example, just to illustrate you that that's the case. Okay, so hello world dudes. Okay, so and I can go and open you this particular page, and you can go and see that it's just a PHP script, a simple PHP script. Okay, a simple PHP script that prints out this information just to show you that, okay, that works. Okay, so you can kind of drop any file into this Apache server. Apache server will simply automatically serve your PHP files into this from this server. Okay, but that's not what I would like to discuss today. I would like to discuss the databases. So how can we go and interact with our database? Okay, for that we have a special web application called phpMyAdmin. Okay, if I come here and then click this thing, okay, it will go and open me this particular window. And this particular window, I have a GUI, okay, access to my MySQL server. MySQL server is running already. I just need a GUI for that. So phpMyAdmin is a web GUI, a web application that helps you to interact with the database here. So okay, let's go and okay, I have a console here. I can go and type in anything inside a console. Like for example, I would like to run something or just create something without going and clicking something. Okay, but I think for you as well, okay, it would be easier for you to learn. Go and click things, okay, here and then do certain things. Okay, so let me go and introduce you some databases that we will be using in this lecture. So we'll have okay, 3 databases that we will use in this lecture. Okay, the Simpsons database contains 4 tables: students, teachers, courses, and grades. You can see that the students contains 3 columns, and then teachers just 2 columns. It's an ID here, and then the name and the teacher ID and so forth. So okay, there's something that we need to know about these databases. First of all, in a relational database, okay, every table must have a primary key. So what is a primary key? Primary key is a set of attributes that uniquely identify a record in a given entity. Okay, so this table is a one single entity. It's a student's entity, right? And the record here is just a row, right? So a primary key is just a set of attributes, a minimum set of attributes, okay? Minimum set of attributes, that's something that I've missed, I guess. The minimum set of attributes that uniquely identify a row, okay, a record in a given table. So, okay, there's a second aspect for the primary key that okay, if it uniquely identifies, okay, a row, then it's called not a primary key but a candidate key. So we may have multiple candidate keys in a given row, okay? So one candidate key for this table is ID, and the other candidate key for this table is ID, name, and email. So ID, name, and email, the set of three attributes uniquely identify a record in this table. And it might sound okay, I mean, just I'm including all the attributes. Obviously it will go and uniquely identify a record. That is kind of trivial, right? But that sounds trivial, but okay, that is a candidate key too, because again, according to the definition, it uniquely identifies a record, right? So what is primary key? Primary key is a candidate key that we selected, okay, for that particular table. We are using this as a primary key. Why it is important that we tell the database management system that among these number of candidate keys, we're choosing this particular candidate key as a primary key. Okay, we have to tell it to the database management system, okay, while creating a database, a table. The reason is the database management system will go and use this primary key, okay, as an index, okay, to find the record. So it will be easier for the database management system to do all the joins and to do all the, okay, data retrievals, okay, through this primary key. So it will be very efficient for you to go and find something through this primary key. In fact, it goes and orders, okay, your records according to the primary key that you set for that particular table. So the data will be physically will be stored in this order, okay, most of the times, okay, according to whichever primary key you set, the data will be ordered in that particular way. So it will be easier for you to, for the database management system to go and find something, okay, okay, based on the primary key. Okay, so because we have two candidate keys, this set, okay, let me just draw it, okay, just to make sure you can understand which columns I mean. Okay, so I got a pointer here, right? So this could be one candidate key, and this entire set could be another candidate key, right? So this is, let's say, candidate 1, and this is another candidate, right? Candidate 2. So when I'm designing this table, I can go and set it to as PK, a primary key, okay? So what about this table? Okay, this ID field can be used as PK. Okay, here I can go and use this ID as PK, right? And in this case, okay, what is the primary key? Okay, so do I have an ID field here? No, okay, but okay, I can go and look into this and I can say, okay, maybe these two columns could serve as a primary key, right? So why these two columns serve as a primary key? Because if I look into this, okay, try to understand how it works, okay, I just need to be able to join these tables, okay. There is another column in this table which is called a foreign key. So you can see this is a foreign key. So what is a foreign key? Foreign key represents a different table on this table, right? So teacher ID is a column which represents a teacher's table here. That's why it's called a foreign key. I usually call it as an ambassador key, okay? So it is an ambassador coming from the teacher's table to the courses table, okay? And this, like, this ambassador is usually a primary key in its own table. So like this teacher's ID is a primary key, okay, in teacher's table, right? So this ID and this teacher ID are kind of equal. So this is called a foreign key, right? So if two tables want to establish a relationship, for example, the courses and teachers, they want to establish a relationship, right? They want to, let's say you want to connect teachers to, okay, courses, then, okay, and depending what sort of relationship they want. For example, if in this case, if one teacher can teach multiple courses, but each course has to be taught by a single teacher, then there is a one-to-many relationship. There is a one-to-many relationship between teachers and courses, right? So teacher wants to teach one teacher teaches multiple courses. That's why this, okay, this symbol is used. One teacher can teach multiple courses, but one course is taught by a single teacher, not by multiple teachers, but single teacher, right? So this is called a one-to-many relationship. So if teacher's table wants to make a one-to-many relationship with courses table, then teacher has to send its primary key, this is a primary key, as a foreign key to this table, right? So this teacher is sending its primary key as a foreign key to this table. And that's how these two tables will establish a one-to-many relationship in the world of relational database management systems, okay? So that's the way how you connect these two tables. So in this way, if you would like to find, okay, Krappabell's lectures, okay, courses, what you will do, okay, you'll say, okay, you'll go and find the ID of Professor or Krappabell, and then you'll find all the courses with the same ID. So in this case, Computer Science 142 and Informatics 100, okay. These two courses are taught by Mr. Krappabell. You can go and find this out easily, right? Just following from teachers to courses and so forth, okay? So that's how we go and establish a one-to-many relationship in database. What about many-to-many relationship? We will have many-to-many relationships, right? There will be one-to-one relationship. Okay, in one-to-one relationship, then okay, there is no necessity. Most cases, okay, sometimes you will have like optional data, something that whether you want or not. But in most cases, the one-to-one relationship, if there is a one-to-one relation between entities, then it's better to merge the data tables into one table. Okay, because obviously, okay, if every Bart has a single email, and if every email belongs to a single name, then it's better to go and merge them into one single table, right? So that is kind of obvious, okay, if you think in that perspective. So one-to-one relationships usually are represented within a single table. But we can have a many-to-many relationship as well, right? So in this case, okay, let me go and show you that example, okay? For example, I got a student, and I got a Computer Science 142 class. So Bart can take this class, right? Bart can take this class. Milhouse can also take this class, right? So this course can be taken by multiple students, right? So one student, okay, multiple students can participate in this course, right? So Bart can take this course, Milhouse can take this course, Lisa can take this course. Okay, so you might say, okay, maybe there is a one-to-many relationship, like one course can contain multiple students, right? So that could be like your option, right? So one, like for example, computer science 142 contains multiple students, okay? Because Bart can be enrolled to this course, Milhouse can enroll, and Lisa can be enrolled to this course, right? So that could be your way of thinking, right? But okay, but Bart can go and enroll to 143 as well, right? Okay, or 102 or something like else, right? So one student can also enroll to multiple courses, right? One course can contain multiple students within it, but one student can take multiple courses too, right? Not just a single course, right? Like you're a student, you have multiple classes, right, at high university. So the same goes here, same goes in the opposite direction. So one student can choose, can enroll to multiple modules, but one module can take multiple students too. So there is a many-to-many relationship between students and courses, right? So in this case, what should we do? Okay, in this case, what should we do? Can we go and solve this problem by just exporting each other a foreign key? Now, in this case, it is not possible. I mean, if there is a many-to-many relationship, you cannot solve the problem by, student go and exporting its own primary key as a foreign key here and then here. No, it will be difficult to go and, do the query here and store the data. So in this case, you will need to go and create some entity, a weak entity. It's called a weak entity sometimes. Okay, which will join these two tables. And this weak entity must contain foreign keys from these two tables. For example, so the primary keys from these two tables as foreign keys. So this is a foreign key and this is a foreign key. And this one belongs to students. Course ID belongs to courses. So this weak entity must contain two foreign keys, right, from the tables that it kind of joins. So now we can go and give a name to this weak entity as grades and say, like for example, Bart can take computer science. Okay, how we go and represent that? Okay, we go and write down the Bart's ID and we go and write down the ID of the computer science. And then we can go and put some additional information about Bart taking this particular course. In this case, the Bart taking this course results in some grade. Okay, so we can go and write down some grade here, or something additional that is resulting from Bart taking this course, right? So we can go, the most important thing is we're kind of joining these two records together, okay? And we can see that, this is Bart. Now Bart actually took this course as well, right? This course as well, and it is like 1002. So Bart is kind of taking two courses here, right? I can see Bart is taking two courses, but I'm curious who else took 13001, okay? So I can find here that, someone else took 13001, and its ID is this. So Milhouse took the same course. So you can see that the opposite direction that this course is taken by Bart and Milhouse, but Bart himself took two courses. Okay, so like one to many in this direction, one to many in this direction. All of that is represented in this table. Okay, through the foreign keys, and some additional information like grades can help you to deal with that, right? So if you look into this particular table, you can see that courses and the grades have one-to-many relationship because course exported its primary key as a foreign key into this table. Therefore, they have a one-to-many relationship, and the same goes for the students because students table also exported its primary key as a foreign key to this table. So now you can see that all of our tables are somehow connected, right? Teachers is connected to courses, courses is connected to grades. Grades is, okay, students is also connected to grades, right? So it means that I can go and retrieve any data in any different way, okay, and then in a meaningful way, okay, from this structure, okay. So that will be my kind of database structure, okay. So that is the kind of relationship I see in these tables, and I can draw the same relationships here, okay. So that's kind of something that I can use while designing a database, okay, for a particular purpose. Okay, so I think it's clear now. So let's move on. And finally, we have IMDb database. The IMDb database, okay, I forgot to mention about the world database. Yeah, the world database basically has three tables: countries, cities, and the languages. And you can see that, okay, the cities are linked to countries through the code, and this code could represent the primary key. And the country code here, as you may guess, it's a foreign key, right? Which links, okay, cities table with the countries table. So one country can have multiple cities, right? And you can go and find out how many languages are, okay, used in that particular country. So again, the languages table is using a foreign key. The foreign key is, okay, coming from the database table, the countries table, right? So these are foreign keys, okay. We can go and have, okay, primary key for every table. For example, okay, this language and the country code, or just the language, could be language and the country code. Language and the country code could serve as, okay, a primary key for this particular table, right? So I assume that, okay, if you go and write Pashto in Afghanistan, there is no need to go and repeatedly write another Afghan Pashto, okay, because, okay, it basically contains percentage and obviously the official or not official, true or false. Okay, so all that stuff, okay, cannot repeat multiple times. So country code and the language could uniquely identify a record in a given table. So I can go and represent these two columns as the primary key for that particular table. And you can draw the lines based, if once you go and identify the foreign keys and the primary keys, it will be easy for you to go and draw the lines, okay, to understand the relationships between these tables, okay. And same goes for the IMDb database. We have primary keys here, okay, and then the foreign keys and primary keys. Okay, so I can go and call these IDs as primary key, right? So these are the primary keys, right? So I can go and call them PKs, and this is a PK. Okay, so, and these are it's coming from the actors table, right? So actors table is a foreign key. This is a foreign key, and its combination is a primary key, right? So we can go and look about movie genres, okay? The genre and okay, this is a foreign key. This is a foreign key, and together they make a primary key, genre, right? And this is a foreign key. Okay, and this is a foreign key. Okay, and together they make primary key, right? So you can recognize, okay, the weak entities here. Okay, we got two foreign keys here, we got two foreign keys here. So it seems like these tables and these tables are somehow, okay, weak entities. So they go and join two tables into a many-to-many relationship. Okay. And yeah, so and then genres, okay, so this is, so movies, and like this movies table and the movie genres, they have a one-to-many relationship, because like one movie can contain multiple genres, okay, and then but every yeah, so in this case, yeah, just like every genre, and this it's slightly blurry here, okay, but just this genre can repeat multiple times. But okay, so what you're saying is that one movie can contain multiple genres, okay? That's what we are trying to achieve here, okay? Because it just has a one single field, simply keeps repeating, no problem. Okay, cool. So I think you have a good theoretical understanding of the databases and their relationships, okay, and the way how they link to each other through the means of primary key and foreign key, okay, especially the relational ones. Now let's go and discuss about the SQL basics, okay? So just go and run some SQL queries, okay? So for that, we should be able to go and set up a database in our database management system. Okay, so how can we go and do this? Okay, so let me go and go back into my phpMyAdmin. So I'll go and click into this new here, and let me go and create a world database, right? So this is the world database. Okay, I already got the SQL for this world database. So what I did is I just wrote the name of the database. Okay, so let me go and repeat this. I just write the name of the database. I just leave it as it is. It's a general, okay, encoding, UTF-8 encoding, and then press create. And as soon as I go and press create button, it goes and, okay, creates a database. I can see the database here. The next thing I need to do is, okay, I can go and create tables, okay, for example, users. I can go and specify the number of columns I want, okay, and I go and press go. Okay, I'll basically create such table myself later on, but what I want to do is I would like to take the data, okay, from some external file, okay, because I already got the SQL for that database, which basically creates all the necessary tables and populates those tables with the data. Okay, so I got this world.sql file. I actually included this into my lecture examples, so you can go and get it from my lecture examples. So I'll share the link, obviously, but I can go and open that, and then I simply go and press go button. So you see this small go button, don't miss it. So every time you go and press go button, it will go and import all the, okay, data that is written inside this SQL file. So it's just an SQL file. It's a text-based file. You can review this file if you want, and you can see all the different things that it did. Okay, so what it did is it went on and just created some tables. Okay, so it went on and created cities table. And you can see that it created a countries table, and I think it created a languages table. So this is just the SQL that it executed. After creating the languages table, it went on and it just added all these records into these tables, right? Now I can see these tables here. Okay, but what I want to do is I would like to go and execute some SQL queries. Okay, so for example, I would like to go and find a city name whose ID is, okay, 17. So let me go and do that. So I can go and say select name from cities, okay, where ID is 17. So I can go and press go again, and here we are. The city name is called Almere. Okay, so this is the name of the city, right? Almere is the name. I can go and put star instead. Okay, in this case, I'll get all the columns. I can get ID, I can get Almere, and I can get the country code, district, and the population of the Almere city, right? So I can go and insert new things into this one. Okay, so let me first. Okay, this is how you can go and connect to the database from the command line. Just go and write MySQL and your username, and then -p. It will ask a password, and you can go and use my world, and then show the tables and everything. So you can go and do the same thing in the console. Okay, so this is a simple select statement. In the select statement, you can go and project the columns and then specify the table itself. So for example, let me go and execute another query. I can go and say select name, right? And what was that? Code, right? Name and code. So I can go and say name and code from countries. Okay, so if I go and do this, I can get, okay, basically does some pagination. I can get all the countries and their country code here, right? Okay, good. So this is just the syntax. I mean, syntax is pretty obvious. So I can go and use certain clauses here. For example, the distinct, okay, will go and return me the unique values only. For example, I can go and say, if I go and say, so if I'm kind of don't know what kind of columns I have here, I can go and use this GUI, okay, to just see different column names here, okay, for my different queries. So for example, I can see that, okay, I can just turn off these columns for now. I don't need them. I can see that language has, okay, a language column and then country code. So what I can do is I can say, here I can say language from languages, right? And if I do something like that, you can see a lot of, okay, a lot of duplicate languages, okay, English, and all that stuff. Uzbek, by the way, okay. So you can see all these different duplicate languages, okay. So if I want to go and select only distinct ones, I want to know how many languages in the world, sorry, so distinct, then I can go and say distinct. It will return me, okay, all the languages in the world and only the unique ones. And I can go and see, okay, there are 457, okay, languages available, I mean, are used in the world by just using this distinct modifier. Okay, I can go and use the where statement, where close, the where close. I can go and say, okay, something is equal to something. Okay, if it's a string, I have to wrap it up with this column, sorry, with the double quotes. And I can go and use some, let's say, logical operators like this, okay, greater than on this one. There are also other ones like, for example, between, okay. So I'd like to go and find out, for example, this is not equal, okay, this is not, it means not equal. For example, I can go and use a between clause. For example, I would like to go and find countries whose population is between 1 million and 10 million, okay. So I can go and say select and then star from countries where, okay, so let me go and find out which columns are there. So I got a population, this one, so I'm gonna say where population between 1 million, right, and say 10 million. So I can, yeah, let me go and say 10 million, right? So you can go and press go, and indeed I have Albania and I have Ireland, Hong Kong, Haiti. It has a 6 million, okay. So these are the countries who their population is, okay, from 10 million, okay. So something like that. Or I can go and use, okay, in for purposes like I just want to know countries who have, let's say, who speak like both English and, let's say, French. Can I go and find such countries? Okay, let me go and go to the languages here. Oops, languages, right? And I can say language must be in English or French. Right? So So I can find out like all the countries which speak either English or French. Okay, so I can go and find out that thing here too. Okay, so these countries speak either English or French. I can go and use like as well. Like for example, I would like to find countries which start with letter Z, for example, right? So I can say name. Do I have a name field here yeah, I got a name field here, so I'm gonna go and say name, like, and I can say Z, and then I can go and put some placeholder. Let's say that this placeholder is a percentage sign. Let me make it a little bigger so you can go and see everything in my screen. Okay, so I can go and write down something like that, and it will go and find so world countries. Sorry, so I got a problem here. So I have to say countries, and I press go. And I have two countries in the world which start with letter Z, Zambia and Zimbabwe. Okay, so I can go and use like for that purpose. Okay, good. So I hope the basic queries are great. I can go and use logical operators, for example, and or to increase the number of filters that I would like to use. For example, I want to find out all the cities in the US whose population is greater than 2 million. I can go execute this query for that. And the like pattern can be used like this. The percentage sign is just a placeholder, okay, for any character in any amount. Okay, so I can go and use the order by statement if I would like to sort data based on the population. For example, I would like to sort all the countries based on their population, and I'd like to know whose population is greatest. So what I can do is I can say order by population, and if I say okay, it will go and start from from population is 0. Okay, it's in an ascending order by default, but I can go and say descending order, and if I say descending order, then I'll see China and India and then United States. Okay, so these countries have the most top population in the world. Okay, obviously this data is old, but still, these are the top countries with the biggest population in the world, right? So I can go and use the limit. Limit will just give me the top 5 top this one, because let's say I might have, in this case I'm getting all these records. In this case, yeah, your phpMyAdmin does that nicely with all this pagination and everything, but in reality when you're querying these databases, you don't get the data in a paginated form. You'll get the entire data, and imagine that you have like a database with million records, and if your query fits million records, obviously you don't want to download all these million records. In this case, you would like to limit your results. So you go and say limit 5, it just gives you top 5. So you can go and skip 5 and then take 5, right? So skip 5 and take 5 means skip 5 and take 5 means that you go and get next 5 countries. So it will be Pakistan, all that, Russia Federation and all that stuff. So this is the 6th one, and this is the 7th, and then and so forth. So you can see that you can go and do the pagination of your database data tables in this way. By the way, what is a pagination? Pagination of your data is breaking your data into small pages, small blocks, and then sending them to the client, because your data is too big to be sent in one batch. So you break it down into small batch, like say batch of 5 records, and then let the user navigate through these batches. It can go back and forth between the pages and see the batches of 5 records. So it will be easier for the user. It will see, you can navigate, and then it's also like increase the performance. Okay, so this will represent, okay, the second page. Third page represents this. Okay, so you skip 10 and take the 5. So if you're paginating your data based on the size of 5, then okay, you have to simply multiply, okay, 5 to the number of pages you have. For example, P can represent the page number. In this case, it's okay, P minus 1, sorry. So it's a third page, it's 10, and then the fourth page it will be 15, and so forth. Okay, so that's something that people use, especially when they're developing a web application with a pagination. Okay, so you can see all the tables here from the command line. So you can also insert something into your database, right? So let me go and do some modifications into a different database, not into the world's database, right? So let me go and create a Simpsons database. So I can go and create a Simpsons database. I'll go and press new. Okay, let's just leave it. And I'll say Simpsons. I'll just write down Simpsons and press create. So now I got Simpsons database. I can go to import and then press choose. And I'll go and create Simpsons. So, yeah. And press go here. It went on and then just created some records inside Simpsons database. So now what I want to do is, I can see all the students in this database. I'd like to go and add new student into this list. I can see there are already 4 students here. I'd like to insert the 5th one. How can I go and do this? I can go and write an insert statement. I can say insert into table, and then the values, and then the values, after values I have to write down everything according to the order of, these are the columns here, according to these columns. So for example, if I say insert students, insert into students values, and I just open the parentheses here, and the first value is going to be the ID. So what is the ID? It's 7789, and then I think Nelson, I guess, right? And some email. Let's go and write some email here, and the password is just password, like that, right? So I can go and write down this statement and press go, and it goes and adds this student into my list. You can see now I got Nelson here, it's added here, and then I can simply executing this query and I see all these statements here. So I can go and insert multiple values. I can go and insert only selected values like this. For selected columns, for name and email. So in this way, I can just simply let the database to auto assign the ID instead of me going specifying it. Or I can go and say replace. Replace is just like insert, but it will if it will go and add student if the student ID is not existing. But if the student ID exists, then it simply goes and updates the student. So it's kind of like you can go and update something without going and retrieving the data back and then forth. It's kind of very easy way. It helps to update. Usually when you're updating something, you have to read first and then you have to update. With replace, you can simply do it in one shot. So you can go and say, if the ID exists, then simply I overwrite the data. If ID doesn't exist, I'll go and create a new one. Update is something like you can go and do something for an existing student. So you can go and say where ID. Make sure that you specify the clause here. If you miss this part, then you're going to update all the records in your table, which is very, very bad. You have to be very careful when you're writing this kind of update statements. Why? Because in the where clause, you have to write down the ID. If you miss this part, then it will go and set the email of all students to this value. Obviously, that's what you don't want to have. So you're going to say the column name, the value, comma, column name, the value. That's how you're going to write that. And the delete is also okay, a very critical thing to do. Okay, when you want to delete a record from the table, you have to specify the table name like this, and then the ID of that particular record. Okay, the primary key, you have to specify the primary key, so you uniquely identify that. Okay, so very, very careful. If you miss this part, then what it will do, it will truncate your entire table. It will remove all the rows in your table. So when you're executing this kind of queries, make sure that always select only single record that you would like to delete. Okay, so these are dealing with records. Okay, you can go and add records, you can go and update records using either replace and update, but replace is safer than update. Why? Because in the replace you specify, okay, and it's not safer, okay, as long as you go and use the ID, it will become safe. Same here, it is the safe. Okay, so and the delete, okay, just for manipulating the data. But sometimes you want to define the data, the structures as well. I mean, the tables it's themselves, right? Or create databases or drop databases, and you can do them from console as well. But if you're using a phpMyAdmin, then everything is kind of represented as a GUI button. Okay, so you go ahead and do this one. So let me go and create a database. Let me call it customers. So I can go and create a database called customers, and I'll be creating all the tables here myself. Okay, so my customers table, let's make sure that it contains only one table called customers, or call it accounts, for example, right? And so now, okay, it's asking me to provide these 4 columns, okay, that I would like to use in this particular field. So first column, I'd like to name it as the ID. Let me go and make it slightly smaller. Okay, so I'll go and say ID. I want it to be an integer. Okay, and so by default, okay, I mean I set it as an integer, but I can go and set the auto increment on, and if I set it to auto increment on, it goes and sets it by default as primary. So this will become a primary key in my table. The next thing is, let's say, the full name. And here I define, let's say, the name of my account, the username or full name. Let's say username. And it must be non-null, right? So how can I go and enforce that? Okay, so if I select this, then it will accept null, but it will not accept null. So it is a forced. It is the value that needs to be given by the user. And then I can say full name, and the same as varchar here. Let's go and give one file, and let's go and call it some email, for example, right? So this is the email. Let's go and make it varchar as well. I can go and use date and then text or any other numeric database data types, okay, float or time. Okay, this text is something that can be used if you have a text file, text data which you are not going to use for searching, but you just want to use it for storing. Okay, it's a blob data type, and it doesn't have any limited size. Here we have a limited size. We're saying, okay, this is the maximum number of characters this field can contain. And if we go and limit it like this, then okay, the database management system will be able to set it up, okay, in an efficient way for retrieval and for storage. So if we are going to use these fields for search, then we have to set them to varchar. If we are not going to use this field for search, then we can go and use text, because text has, okay, and can contain, okay, any number of characters. But you have to be careful about using text, because like you don't have to use text everywhere. You have to use text when your textual data doesn't have any limitation. For example, a comment or an essay or description or anything else. These are the appropriate cases where you have to use the text. Okay. So let me go and write down the size again. Let me go and leave. Make email as, okay, nullable. So I go and press save now. And now I have a data. Now I have a table, okay, with 4 columns in it. Okay, it has a primary key, which is ID, and it has 3 other columns. Okay, which are varchars, and this is nullable. Okay, so now I can go and insert values into this database. But before I can go and do this, I can go and do it from here, right? But now I would like to use this database, okay, from PHP. And I'll show you the examples, okay, when I come back into the PHP part. But now I was able to create a new database, and I was able to, okay, create this table and its primary key and everything, right? So, okay, I can go and define foreign keys as well, okay, by just adding additional, okay, constraints into this. Okay, in this case, I can, yeah. Okay, so if we would like to create a foreign key, so we can go and click this particular option, the relation view, and then here we can go and give a name to, because it's a constraint, and every constraint in any given table needs a name. So you can go and give a name to this, and then you can go and choose a column, like the column which represents a foreign key, and then the database name, table name, and the column name. So currently we just have only single table here, so you can go and select that and then press save. So this way, okay, these are actions that you would like to do when you a record with the same ID is actually removed. Let me just explain it here. So we have these tables here, right? We discussed about these tables. So imagine this table here, okay? So for example, we got students here, right? So and then this student ID is participating in this grades table, right? So if I delete Bart from the students list, or okay, or something unusual, like, I mean, if I can go and change the ID of the Bart, which is going to happen really rarely. Let's assume if I go and delete Bart, okay, so what would I want to do with these records? Okay, obviously these IDs won't exist in the students table, so it will kind of break the integrity of my database, right? So I would like to make sure that the keys that in the foreign keys that are found in different tables, they could be matched to a record in the corresponding table here. So I can make multiple different decisions. One decision is, okay, just leave them as they are. Okay, the second is restrict this record from deletion. So I cannot delete this record unless I go and manually delete all these records here. Or I can go and set the cascading. I can say, okay, if I delete something from here, cascade my deletes into this, okay, section, and then so forth, everything. Okay, so the deletes can be cascaded down to all the relevant tables, and all these records will be deleted. Okay, once the the ID that represents that particular record is deleted from its main table. So that means, okay, that this on delete actions actually mean this thing. Okay, set null simply replaces that particular value, okay, that is in the where it sets the foreign key column, okay, to null. So you can go and choose one of these actions. Okay, by default it is restrict, which means that, okay, you cannot delete a record from students table, okay, if that student has records, okay, somewhere else, let's say in the grades table, right? So you have to first go and clear the student grades, and then you can go and delete the students. Okay, so these are kind of certain restrictions you can put, certain constraints you can put on these tables, along with the foreign key. And these foreign keys can be inserted from this particular option here. Okay, so let's continue our introduction to SQL and MySQL database management system. We talked about limit, we talked about insert and replace, update, delete, creating and modifying tables. These are just SQL statements that allow you to do the modification. Okay, you can go and run those SQL commands, manually, or you can go and do those things in GUI. Okay, why do you need those things to be written like this? Because you would like to go and dump everything, okay, into some SQL file. So for example, you can go and go to export here, and in the export you can go and select the format for example SQL, and then press go. So if you go and press go, it will go and export the structure of this table, or you can go and export the entire database, okay, entire database inside your entire database in this MySQL. So you can go and see, okay, all these SQL statements that that mean that actually write everything in this format. So basically you can go and create all these databases, the tables and the columns, okay, using the SQL as well. Or you can do the same thing using using the GUI like phpMyAdmin. So these are the available data types in MySQL. You can see the varchar and integer, and then there's also a float. Okay, double dates is also available there. Okay, and like some small databases like SQLite, you don't have date fields. These are kind of represented as simple varchars encoded in a particular form, but MySQL has a dedicated field type called date, okay, which stores dates in its corresponding format. It also has blob data types. These are used for like storing binary data, or there is also a club. Club is a character large objects, which is like a text. Okay, so text files could be stored in this particular data type. So we can, as we already mentioned about varchar in a text type, okay, the text type is something that contains arbitrary number of characters, but you are not going to search within those characters. Okay, if you want to search something, okay, then you have to go and create a varchar instead of a text. Okay, and then there you have to give the maximum length of a string that you'd like to store. MySQL is a quite powerful database management system. It contains many other data types, like for example the geometrical types as well, like points, lines, and polygons. Okay, so you can go and store these kind of data types as well, along with blobs and everything. So you can go and learn all about the MySQL database types, okay, from these documentation. Okay, just click this link and you find out all the available data types there. Okay, but most of the times you're going to use all of these data types. And this is how you're going to create tables and then different types of tables using pure SQL. Okay, let's go and review the Simpsons database. Okay, we already talked about the Simpsons database, but let's do some practice. Okay, so the first question is, okay, what courses has Bart taken and gotten B minus? Okay, did I talked about that? No. Okay, so here I just need to learn information from two tables, right? So how can I go and do that? For that, I will need to use join. Okay, so join will join two tables based on a certain parameter, certain attribute. Okay, so for example, okay, there are multiple different joins. Okay, so the cross join is sometimes called a Cartesian product, which is like the mapping of every row in one table A with every row in table B. Okay, so this is kind of like it will produce m multiplied by n rows. Okay, so if m is the row for table 1 and n is the number of rows in table 2. Obviously, most of the times, okay, this kind of mapping is kind of all the possible kind of mapping between these rows, but most of the times it is not relevant. We don't want this entire mapping of these records, okay, as a result. We would like to filter through this, okay, mapping. So what we usually do is instead of using a cross join, we use an inner join, okay. The inner join is a different type of a join where we have to filter from that available mapping. We have to filter only those which satisfy a certain condition, okay. So how do we go and write down that condition? We say, okay, select certain columns, the table 2, okay, on, and then we just go and write down certain condition that can be used, okay, to filter the records that are mapped, okay, in these from that list, from that Cartesian product. And most of the time, these conditions are just the mapping between the primary key and the foreign key. So remember, we usually go and use relationships based on primary key foreign key relationship, right? And when we are joining tables, okay, we usually want to join them, okay, using primary key foreign key relationships. Why? Because it's faster. Because we know that all the tables are indexed by their primary key, and because they are indexed by primary key, it will be easier for the database management system to go and retrieve these records. Okay, if you go in a reverse direction, it'll be easy for the database management system to go and find a student, okay, student ID based on his ID, okay, rather than his name or something else. Okay, so for example, I would like to go and see all the students and their grades. Okay, so how can I go and join these tables? I have to say students' grades on ID of the students table and the student ID. Okay, so this is going to give me this particular record, so I can see all the fields here, ID of the student field, student ID here, everything. But most of the times I don't need, okay, there's all the fields here. So I can tell, okay, just give me the name and the grade. Okay, so how can I go and do the projection on the columns? I can say, okay, name, course ID, and the grade. And then I can go and put some filters here. I can say, okay, I just want only Bart. I don't want Ralph, Milhouse, or Lisa. So I can say where name is equal to Bart, right? So this will give me the grades for Bart for a given course ID. Okay, so but yeah, so yeah, what if I just want to go and get information about the course itself too? So what should I do here? I mean, I just want to know the course name too. So in this case, I have to go and join courses table too. So let me go and write down this query. Let me go first into the Simpsons database. Right, I'll go and select SQL, and then I'll go and say, let me make it slightly bigger. I can say select. Okay, so I can, let's just for the beginning, let's go and select everything from, so I'll go and say from students, and I can say S just to kind of use a shorthand notation. So I can go and say, let me go and make it like that. So I'll say join grades G, and I can say S ID is equal to G student ID. And let me go and join courses as well. Let me give a name C to that, shorter name, alias. Okay, so I'm gonna join G because I have G course ID, C ID, right? So here, what I want is I want the name of the student. I want the name of the course. So I can go and say course name here, just to give a different name to this column. And I can say student name, and I can say grade. So G grade, and I say grade. Okay, so if I go and press go, I'm going to see a table with 3 columns: the student name, the course name, and the grade, right? So, but I want the grade only for Bart. So what should I do? I'm going to say where, okay, S name equal to Bart, right? And then if I say go, I'm going to see Bart's grades, okay, for 2 courses that he took, right? So these are, so these are just examples of using SQL join, okay, to join multiple tables, do the inner join, right? And I can go and define different criteria. I would like to go and find all the students who got less than C. Okay, so what I'm doing is I'm saying less than C. This comparison works in a lexicographical way. So the A is less than C, and then D is greater than D is greater than C because the D comes later than C. So if I say a grade less than C, which this means, okay, not a worse grade, okay, but just a grade which is above C. So B minus or B plus or A plus will also be less than C in this case, okay, in the lexicographical terms, right? Because it like the earlier the letter appears in the alphabet, okay, in ASCII code, the less it is, okay, compared to the other ones. We can do multi-way joins. Okay, so in this case, I'm joining 3 tables and finding, okay, so what I'm finding here, I'm finding the name of a course on which Bart got anything greater than, okay, or less than B minus, okay. So it's just the name of the course, right? So these filters, I can go and apply multiple filters using logical operators like that. Okay, so now it's just an exercise. The exercise is I'd like to go and find courses that have been taken by both Bart and Lisa at the same time. So what should I do? So I think it will be easier for me to draw that. Okay. Well, let me go and draw that for you, so it will be easier for you to understand how I'm going to construct this query. Okay, so let me turn it on. So what I want is the course names, you can call it, that is shared by Bart and Lisa. So let's imagine that, okay, I would like to go and find all the courses that Bart took. What should I do? In this case, remember I have students table. I just need to link it, okay? You know, it is linked to grades, right? To grades. And the grades also is linked to courses, right? So through the grades, I can go and learn through this table, grades table. I can go and learn the courses that are took by one particular student, right? Only one particular student. So if I go and write something like that here, right? So just ignore this particular SQL statement for a minute. Look into this. Okay, so I got students, grades, and courses. Okay, so now if I want to find only Bart's courses, then I just need to go and put a where statement where the student name is equal to Bart, for example, right? But if I want to do the same thing for Lisa, then what should I do? I have to set it to Lisa, right? So you might go and say, okay, let me go back into the phpMyAdmin. So you might have following statement. You might go and write following statement. So what you're looking for is course name. So you're going to say course name. Okay. So you're going to say from students join grades G on S ID is equal to student ID, right? Oh, sorry, grades. So you're going to say grades student ID, and then you join courses, say C on C ID is equal to G course ID. So you basically joined three tables through their primary key, foreign key relationships, and then you can go and say, for example, S is the table that you would like to get. So you can go say, I'm looking for courses that are taken by Bart. That's how you're going to filter that, right? And indeed, it gives you these two courses that are taken by Bart. We can go and kind of mentally agree on that. Let me go and show you the table itself. So I can go and show you the table. So you look into this table and you can figure this out yourself. So Bart's ID is 1, 2, 3. Okay, Bart took two courses, and these courses are 1301, 1302. These are the two courses that Bart took. Computer Science 142, Computer Science 143. And indeed, we see the same result here, right? Okay, so what if I want to go and get Lisa? Then all I just need to go and do the change the name for here, Lisa. I can go and do Lisa here, and this will give me Lisa's courses. But now I want the courses that have been took by both Lisa and Bart. What should I do? If I go and say something like that, obviously I will not get anything. I'm not going to get anything. Right? What I'm saying is, okay, the student name has to be Lisa and Bart. So the reason is, in one record, you cannot have a record where the name is equal to both Lisa and Bart at the same time. That is not possible. That will always give you an empty result. Or you may go and say, or in this case, yes, you'll get a union of, okay, you see this is kind of repeating. So you'll get the courses that are taken by Bart and the courses, okay, that are taken by Lisa at the same. Okay, union it into one, concatenated into one result. What you're looking for is only the courses that are taken by both of them. You don't want, for example, the ones that are taken by Lisa but not taken by Bart, or the other way around. So how are you going to go and achieve this? So one way of doing this is treating this entire thing as if it is just a one big table. Imagine that there is a table which gives you, okay, which gives you the IDs, the course names. So you can go and join these two tables together and then get the ones that are common. Okay, so imagine that there is a one table for Bart and another table for Lisa. So this course, so we have these two, okay, these two tables have okay, columns called names. So we can go and join them based on that. So we can go and imagine it this way, right? So let me go back into this diagram and then explain it visually, and then we can go ahead and then continue. So we got students, grades, and courses. So where is that? Okay, pointer. So what I will do is I will go, I got basically here, I got course IDs, right? So I can just leave courses here. I can go and here I can go and call this particular table as Bart, right? And this one I can go and call Bart's grades and give some alias to this. Okay? So on the other hand, I got another grades table. But in this table, I'm filtering for, okay, Lisa's grades. And here in this students table, I'm filtering for Lisa. Okay? So what I got is I'm using these two tables independently. I'm using one set of these tables, okay, abstractions, just to filter Bart and his grades. And on this other side, I'm using this table again for filtering for Lisa and her grades. Okay, and on these two tables, I have, okay, a crossing, a mapping, overlapping course IDs. So I'll simply join them, okay, I'll simply join them based on their course IDs. I join this entire table with this entire table using, okay, using the course ID, right? So, and in this way I can go and so I go and define some relationship. It will be a one-to-one relationship in this case. Okay, so I can join these two grades together and collect the result. Okay, so let me go and write down this result here. So first, what I will do is I'll call, okay, C, just let C be C. This one, this table, I will call it as Bart. The students table, I will call it as Bart. And this grades, I will call it Bart's grades. Okay? And I'll join Bart with his Bart grades table. Okay, so I'll have another join. Okay, here I'll need another students table, but this time I'll call it, okay, Lisa. 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 Yeah, I'll need another grades table. Grades table, and I'll call it Lisa grades. And this Lisa grades, Bart grades, Yeah, Bart grades has a course ID, I guess, right? Course ID is equal to Lisa grades course ID. And I'll do another join here. In this case, I'll say students Lisa. Okay, and I'll join this students table Lisa ID to Lisa grades student ID, right? And all of that can be joined to, let's say, Lisa grades or Bart grades. In this case, it doesn't matter. I'll say course ID CID, sorry. So courses. So now I can go and say Bart student name is equal to Bart, and Lisa, remember these two are just, okay, aliases for these tables. I can go and say name Lisa. Okay, so if I go and execute this query, I'll just get a single value, the value that is shared by these two students. The course that is shared by these two students. And indeed, if we go and look into the final result here, okay, it is basically the same as given here. This one, right? So indeed, if we look into the initial table that we have here, here, okay, we can see that Bart took these courses, and Lisa has an ID of 888 and 888-1302. Lisa also took this course, and this course name is Computer Science 143. And indeed, we're getting the correct result. Let me go and run it again. We're getting a correct result here. Okay, so again, you have to imagine certain times. You have to imagine, like you can go and use the same tables multiple times. Okay, all you need to do is, okay, if you have certain cases where one table belongs to other tables, okay, because you have to apply a different set of filters to this table, and then you have to apply to the same table with the different set of tables, and then you would like to do certain manipulations with that, you can go and do this using this language of SQL. Okay, so there is no rule that you can only use these tables only once, okay, in your select query. You can go and use them the way you like. Everything depends on the way how you go and construct your queries, okay? Especially when you are dealing with such complex queries, okay? But in fact, just imagine virtual tables. These select statements will give you virtual tables, and you can work with these virtual tables. You can join one virtual table to another virtual table, and as a result, construct something similar to this. Okay, so hopefully that was clear to you. Yeah, it was a little bit confusing, but I hope you were able to kind of understand how to structure joins. Okay. Okay, so designing a query, there is no one set of rules for that, but I would rather suggest you to first start from the critical table, the table that you would like to start from, the lattermost table. Okay, so you have to go and start from specifying that table, and then you connect that table through primary key and foreign key relationships to other tables. And then as you go and connect them, you go and write down joins, okay? And then at the end, once you do the join, you go and write down the filters through, okay, where clause. Okay, and usually at the end, you can go and specify the columns, okay? Using select, you can go and specify the columns that you will need from that, okay, structure, from that query. Okay, so you can go and play with the IMDb database as well. It is given in your lab. The SQL for IMDb database is also provided, so you have to set it up yourself and do some queries, okay, that are asked in your lab. Okay, so you can go and find the database structure here. So this is the ID, this is the foreign key. So you can see the foreign key, primary key, foreign key relationship between these tables here. Okay. Okay, good. So now, what I want to show you is at the end. Let me go and spend a little time there. Show you how to go and connect to this database management system from PHP. Okay, so obviously for that we will have a PDO object, a PHP data object. Okay, so it takes 3 arguments. First is the connection string, and then username, and then the password. And then you can go and run certain queries like this. Okay, but I will show you how to do those things in a safe way. Okay, so first of all, okay, let me go and show you some examples. Okay, and then on that examples I can explain you how to query and then how to add certain things into your list. So let me go and open the PHP Storm here. Yeah, by the way, before we go and use these databases, we should go and create a user for these databases. For example, I can go and create an admin user which can access all the databases in this server, or I can just go and create a single user for only one single database. For example, I can go and select world here, I can go and select operations, and here I can go and sorry, not operations, the privileges, sorry. So here I can go and create new user accounts. For that, I have to go and let's say create this add user option. I'm going to go and edit these privileges. I have an admin account already, and you can see all the passwords. I can go and change passwords. I can go and change the login information. But just for the sake of the example, I can go and create let's say world DB, or I go and say Desmond. Okay, and I can go and generate a safe password. So this is the password that I generated. I can check all. Okay, let me go and copy that password and then press OK. So these are just permissions what that user can do. Okay, and it is kind of can do all the different things here. And not only all the different things, but also can access all the databases. I can access from different places here. Okay, so I got user accounts now. So you can see all privileges are given, can access from any place, and so forth. Okay, so I can go and specify that I use this user to connect to the database. Okay. So in this example, you can see that I got an example already here. So let me walk through this example. So what I'm doing is make sure that I have my database and system running. Okay. So I go and write down a connection string. So what is a connection string? That is the driver, okay, for a database management system. So if it's a MySQL, then it's just simply MySQL. And then I have to provide, okay, the host for the server and the name of the database. This is world. Okay, so I can go and say Desmond here. This is just the Desmond Duza, I guess, right? That's what I created, or just simply Desmond. I just Desmond, and I have the password here. I just copied. Oops. Okay, so I can go and put this password and the username. So 3 arguments. One thing is the DSN or connection string, and then username and password. The next thing I can do is, okay, I can go and get a prepared statement. So if you know how to program in Java, you are familiar with prepared statements. You can go and leave some placeholders like this, and then fill them later on. Okay, so here it will get a prepared statement through this DB object. Okay, in Java it was a connection object. If you remember, in JDBC it was a connection object. Here we can go and get a data object from PHP, and this data object we will be using everywhere to get some other objects. Okay, so for example, a prepared statement, we'll get it like this. We go and write down some SQL statement, and then a placeholder for a place which needs to be filled. Okay, so this is how I get a prepared statement. Now I can execute a prepared statement. So execution of the prepared statement will simply go and send this result, and then it doesn't return you anything. Okay, so it just simply goes and prepares your statement and executes it and stores the results inside the statement. So how are you going to pass parameters into this execute method? You simply need to go and pass a parameter. So what I'm doing here is I'm collecting, if it's a post, I'm collecting the query, okay, from the user, and simply appending this, because I'm using like here, I'm appending this, okay, placeholder, the wildcard at the end, okay, of the query, just to make sure that if I go and just type in T, for example, I'll get all the everything that starts with T. Okay, I'll simply execute it, and then after going and calling fetch all method, I can go and get all the rows. Okay, I can go remember this method, execute method and fetch all method, that are the methods of a statement. Okay, so I'll get all these statements and so forth. So the next thing that I'm doing is, okay, this is my form. I'm getting the query for that form, and this is the city name. Okay, it's just simply getting pre-populated. But what I'm doing here is I'm just iterating through rows. Okay, so I got row collected from this statement. I'm iterating through these rows. Okay, and every row is an associated array. It's a dictionary. It has column names. Okay, so let me show you that I have these column names in the world database. I'm getting things from cities, and these are the column names. Okay, country code, name, and population. All of these are column names. I'm getting those things and then printing them out, okay, iteratively in this table. Okay, so let me go and run that particular script. So you can see that it is running on a different port, not on 8080. Why? Because remember, the Apache is already using 80 just for hosting the phpMyAdmin and all that stuff that I can use to interact with my MySQL. So I'm just running my local host for test server on a different port. Okay, you can go and edit that if you go to edit configurations, and then you can go and change the port number here from 80 to 8080, just to make sure that it doesn't intervene with your Apache. Oops, I'm gonna go and write down localhost now 8080, and now you go. So this is it's showing me all the cities in the world. Okay, but I don't want to see all the cities. Okay, let me go and do some pagination here. So how would I do pagination? A very basic one. Let me go and just show top five cities. So if I go and do something like that, or let me this one. Now I can go and write T, for example, and see all the cities, like top cities which start with T. If I go and say TO, I can see all the cities that go and start with T. And here I can go and find Tashkent. It's just written this way. I can go and find all the cities that start with New York, or I can go and say New York, and then press enter, and then say New York. So I can go and search different fields, different values, and get the names, okay, the cities and their population, all that information from this simple search form. And as you can see, all of that things are getting executed. I can even go and put a breakpoint here just to show you that everything is getting kind of executed. Let me go and try this out. Turn on the debug mode. Okay, if I turn on the debug mode and it's listening, right? Now here it's asking, okay, will you accept? And I'll accept, okay? So you can see the query is Washington, okay, the quick cookies and all that stuff. I can go through everything and then I can go and execute. I can see what is rows now. I got the rows, I got a single row, okay, and I can see all the fields in these rows, okay, the index and the parameter name, all that stuff. I can go and use that for debugging purposes as well. So if you're kind of feeling a little bit not familiar, lost in this code, you can go and turn on the debug mode and then go through everything, see how this whole thing is getting executed. Okay, let me go and show you another example. In this example, it's a customer's example. In this example, I would like to go and add customers into my customers database. Remember, I created a customers database here, right? This is the customers database and I got an account here. So I'd like to go and accept, right? So let me go and stop all navigation. Okay, so I got customers and I got an account here. So what I would like to do is why it got lost? Okay, I just turned off the debug mode for this one. Otherwise, it's kind of okay. Here it is using the debug mode and it's trying to. My phpMyAdmin is trying to debug this page as well. I don't need this page to be debugged. Okay, so I got accounts, and inside accounts I have columns, and you can see that email, full name, username. What I want to do is I'd like to go and add values into this. How do I do the adding? Okay, adding is very similar to querying. I can go and specify, for example, certain parameters with a prepared statement, and I can go and simply execute passing these parameters into the statement. But there's another way as well doing the execution. I can bind parameters to a certain variable name by reference. Okay, for example, I have name and value. All I need to do is I just need to assign some value to this and simply execute the statement. The statement will take all these the values from these variables and then execute this insert statement. So let me go and show you that example, okay, here. So I just need to go and do this. So first let me show you this page. Okay, so there is a page called, let me turn it on. Okay, let me go and say cities. So instead of cities, I'll say customers. So this is the customers page, okay, and it has two fields, name and email. So what I want to do is I would like to go and add records, okay, fill in something and then add something into this page. So I can go and kind of store everything in the database. So I'm gonna go and do that here. So I already have a form. It basically goes into the same form. So what I want to do is I'd like to do some data processing. So usually I go and do it here at the beginning before I even start generating this text. So first of all, I'd like to go and make a connection string, right? So let me go and define a connection string. I can go and create this thing in a separate file. Usually, if it's a big project, I go and define a separate file which initializes the connection string and everything, DB object, and I will include all the file everywhere just to make sure that I don't have to rewrite the same thing over and over again in multiple different places. Okay, so here I'll go and say customers, right? And I hope in the customers table, this user is also valid. So I can go into privileges. Yeah, so this user has access to customers database. Okay, so I can go and edit those privileges and I can restrict that. But my current user that I just created has access to customers table. So what I need to do now is create a statement. In this case, insert statement. Okay. And I'll say insert. DB prepare and insert into accounts. And I'd like to go and add email, let's say username, full name, right? What were the fields here? Let me look into those things. Full name, email, and username, right? So yeah. So let's say username and full name are going to be the same anyway, and then email. So I'll say values. So I need to provide 3 arguments here. Yeah. So that is going to do the insert. This is the prepared statement. Okay. So, when do I need to do the insertion? I have to do it only when I'm receiving data. And when I'm receiving data, when there is a post request. So I'll go and say if post. If post, only then you go and create this connection string. Yeah, and I can go and do the execution straightforward, but let me go and find out the name first. What is name? Name is a request, and here I got a form. This form called the form name is txt name. Let me go and create another label. Call it username or login, because we need that field as well. txt login, and I can go and name the same thing here. It's login. Okay, so this is login. I got a name and I got an email. So I can go and get all the values from this particular field. So the parameter name will be txt login, txt name, and txt email, right? So I can go and say txt login, and this is going to be my username, and this is going to be full name, and password, right? Let me go and call it pwd. Sorry, email, not password. txt email. Yeah, I made a mistake. It's called txt email. Okay, that's how I get all these fields. So what I can do now, next, I'll just say stm execute. I'll say array, and I'll just pass these variables. First is the username, second is the full name, and the final one is just an email, right? So, and that's it. That should be it. Okay, but what if it is not post? It is get. What should I do then? In fact, I don't even need to, I have to do it every time. Okay. What I need to do is I have to show all these customers on the user page. Doesn't matter whether the user, whether this page is accessed using post or using get, right? All I need to do is just render these fields. So how can I go and do that? For that, let me go and put those things here because I will need database connection every time. So let me go and take this out from the scope. Okay. And okay. So let me go and give a name to this. Just don't say statement. Let me go and rename it to insert statement. And it goes and executes that. So I can go and define another statement. Let's go say select statement. I mean, you can go and give meaningful names to this. Okay, you can go and say add account statement and add. Let's be let's be like that. Okay, let's give a meaningful name. Let's call it add account statement. And here I'll go and refactor it. I'll say get accounts statement. Okay, and this one is obviously going to be select. Let's go and select everything, accounts. Okay, so it doesn't even take any parameter, so you can simply go and execute the statement. Okay, so what should we do here? We have to go and get the rows here. So how do we get the rows? First, we need to go and execute the statement, get account statement, and then the rows are fetch all, right? Okay, so we got two prepared statements. We are using this one whenever we get a post request, okay, and we are using this one every time. Doesn't matter whether it's a post request or get request, right? So, and this one doesn't take any parameter, and this one takes 3 parameters. We're assigning these 3 parameters and simply calling that like this. So the next thing that we need to do here is we have to populate the values whenever we receive the data, right? So I just need to go and define these variables outside just to make sure that they are declared somehow, okay? And say full name. Okay, so, and this one is email. And these are just, initially they are set to empty string, but if it's a post, so you would like to, okay, you would like to go and populate them here. So you're gonna say username. So let me go and take the value here as well. Full name. And email. So it goes and populates these text boxes, okay, with the value that has been entered previously. And the next thing that we'd like to do here is we'd like to repeat this structure, okay, as many times as we have, like the number of rows. So I'll go and say for each rows as row, and I open the curly brace. Every time I open, let me go and close it because I can forget about that. I'll close it here. So I got an opened and closed section. In this section, anything that keeps repeating. So I'll go and put that here, and everything else kind of can go, doesn't matter anymore. So here, what should I display? The full name of the row, right? So I'll say PHP, or I can simply go and use the print shorthand, and I can say row full name, I guess, right? And here I can say email. Okay. So I saved everything. So I have this logic, which which adds this to statement, which creates this database object, creates a prepared statement, creates variables that represents the data that's coming from the form, and then executes this statement. As long as it goes and executes the statement, and at the same time it populates this prepared statement with the necessary values like this. Okay, so let's go and see that in action. So let me go and refresh this page. Currently, customers do not have anything. So let me go and say Desmond does Sarvar live, and let's go and select this. I press add. Okay, so we don't have customer. Okay, it's customers. So it was sending things into a wrong location. Now it's, it was even highlighting here. The customers, I missed it. Okay, so let's go and try it again. So let's go and let's say Gmail. And here we go. I have this customer. I can come back to this customer and I'll see that all the time. I will see it all the time. I can go and fill it in. Let me go and write something else. It's Alisher Navoi. Navoi, something like this. And then, oops, I can go and say Ulukbek, Mirza Ulukbek, and another add. And as you can see, it's coming and adding all this information, okay, into this table. I can go and refresh this page, okay. Obviously, all that information is now coming from the database. I can see everything here, and I can show you that, okay, if you come back into your phpMyAdmin, you're going to see all these records, okay, in the accounts table. You're going to see all of these things. So all of them are getting added into your database by just simple subroutine. Create a database object, create a prepared statement, check if you're receiving the data. If you're receiving the data, collect all the input, user input, and then execute the statement. That is as simple as that, okay? Otherwise, if you're not receiving the data, you can go and generate, you can go and grab all the users and then display them somewhere here, okay? So that is just the basic example of how to use PHP to execute SQL statements and to collect information, data from the database. So I hope it is clear. There are certain common mistakes many people make, okay, when they are writing things. Okay, there's one more way of writing things, again, using bind parameter. Bind parameter, okay, sometimes you can find it easier because you have to deal with the variables, okay. Once you bind these variables into these placeholders, you can manipulate these variables and then simply execute the statement without passing the actual values, okay, in this one. But for me, I think this the version that I showed you is easier than this way. Common mistakes, okay, database often fail because because you have like this kind of query where it contains some mistakes. Okay, so if you go and execute this query, if you're using this kind of method query, then okay, you don't need a prepared statement. You can just directly execute a query like this and get rows. Okay, but if you make mistakes, then it will simply return you false. It will not give you an error. Okay, if you want to turn it on, like it cause a certain exception, then you have to set attribute, and then okay, a PDO and an error mode exception. You have to turn on these two okay methods. Only then okay, this method, this query method, or whenever you're executing an invalid query, you'll get the result. Okay, this particular method will throw an exception, a PDO exception. You can capture that exception and then debug your okay program. So it's kind of something that will help. Okay, I can go and write it down. Okay, for example, here I can say so db set attribute. So yeah, so it is PDO at attribute and PDO error mode exception. So PDO at error mode, and I'll say PDO error mode exception, this one, right? So if I turn on these two flags and I make a mistake, let's say somewhere here, then it will cause an exception, and then I will be able to find this out. It says, okay, fatal error, some exception, the SQL statement is not wrong. So it will not execute, and I will know why it's not executing, because this SQL statement is wrong. Okay, so make sure that you turn on these flags, so it will be easier for you to debug your mistakes. You can also okay, put it inside a try-catch block and then catch that particular exception, and then display some meaningful message as well. Okay, so database design principles, they are very simple in this case. Okay, so make sure that your database has every table has the columns that it must have. Okay, and every record should be uniquely identified, okay, by some primary key. Don't overdo things. Okay, make sure that you just go and create things that are just necessary for implementing that particular functionality. Eliminate redundancy in your databases. Okay, if you have something that duplicates, something that is redundant, just eliminate it. Either you can go and split these redundant information to two tables and try to kind of make sure that your data is robust. Favor integers for comparisons and repeated values. Okay, so integers are smaller than strings and better to repeat. Okay, if you have something that needs to be repeated or compared, then you just need to go and use some integers rather than strings, because it's easier to compare integers rather than strings. What about what's good and bad about this design? Okay. Yeah, wait a sec. So the good thing is that it's a simple one. Okay, but there are many bad things about this design. Okay, so just going and writing everything in one table, like the Simpsons table, and call it like student grades, for example. The good thing is that everything is visible to you in this way, but there is a lot of redundancy here. Okay, this email is repeating a lot of time. Okay, this course name is getting repeated a lot of time. If there is a small typo, it turns out that Bart and Milhouse, okay, took different courses, right? And the teacher names, everything is getting repeated. Also, okay, most searches that you do will rely on string comparison rather than an integer comparison. So if we are doing like an ID based search, okay, when we do joins, okay, those comparisons are happening with the IDs, with the integers. Here we have strings. Obviously that will affect the performance of our search queries. And And there is no one column, okay, or like a minimized set of columns that can uniquely identify a record in this table. So there's no primary key column, okay, one single column that would identify this record uniquely. The primary key for this entire database, table, would be all columns, okay. Obviously, that is a bad design, and obviously this big table needs to be split into 4 tables, as we saw in the first case, in the first schema. So look into this table and try to build something similar. So this will be the improved version. So we split it into 4 parts, okay, and then created primary key, foreign key relationships among these tables and made it, okay, normalized, okay, less redundant and easier to structure our queries. Okay, hopefully that will conclude our lecture on databases and constructing application databases and being able to, okay, work with databases using PHP. Hope it was informative, and it was a little bit lengthy than usual, but hopefully that it will help. Okay, so see you next week.